This is Lindsay Peabody, and this is my Matlab project for ABE 205, spring 2012. So I have it here printed out on a Word document so it's easier to follow and go through. And I have my Matlab window open for some demonstrations. So I based my entire project on tennis. It's a sport I've been playing my entire life, and I thought it would be fun to incorporate it into this project. So I have 4 functions in this project, and I started with finding the time it takes for the tennis ball to hit the other side once you hit it. So here I have my input and output. I called this function vTime, and like I said, this function calculates the time it takes the tennis ball to hit the ground on the opposite side of the net after being hit. Here, G stands for the force due to gravity, which is always 9.8 meters per second squared, so that does not change. Y is a constant. It's the height in meters from which the tennis ball is hit, so you'd have to measure from what height you're hitting it. And T is in seconds when it's found. I have a loop in this function because the equation to find the time is the square root of 2 times y all divided by g. But obviously you can't take the square root of a negative, so I had to add in this part here, that if 2 times y divided by g is less than 0, then the answer does not exist. So when performing it in Matlab, this is what happens. I put 9, you open up the function by typing in vTime, and then you put in g, which is 9.8 always, and then you put in the height from which you're hitting the tennis ball, which varies. I put in 1 meter because that's about 36, 37 inches, which is pretty typical. And here it calculated it. The time it took is 0.4518 seconds. And just to demonstrate here, I put a -1 for a height, and it came out saying the answer does not exist because y is a negative value, so you have to choose a positive value for y. And the second function I made is to determine how far the tennis ball will travel horizontally, which would be kind of fun, just to, if you're trying to figure out where you want to hit the ball exactly, how far exactly you want to hit it. And I call this function hdistance, or hdist, which stands for horizontal distance. And here are my inputs and outputs. And like I said, this function calculates the horizontal distance the tennis ball travels when hit from the height used in the previous function, vTime, which uses the time found from vTime. So the VI stands for initial velocity with which the tennis ball is hit in meters per second, not miles per hour. The vTime stands for the seconds to hit the ground on the opposite side of the net, which was found in the previous function, and then X is found in meters. The equation is X equals VI times vTime, and performed in Matlab. To bring it up, you just type in the name hdistance, and you type in your initial velocity with which you hit the tennis ball, which can be measured. And here I just said about 30 meters per second. That seems pretty typical. And then here is the time it took for the tennis ball to hit the other side of the net, which was calculated up here in the first function. So then it calculates the horizontal distance that the tennis ball travels during that time as 13.554 meters. So if you want to see how far you can hit the ball, or if there's a certain place where you want to hit it to, you could potentially use this function to determine how hard you need to hit it to make it go a certain distance. And then my third function is, well, technically there's 4 functions, but this one here is just a little function because in order to calculate my last function, I need to have the area of the tennis ball, which I made into a function here called area, where r is the radius of the tennis ball. The radius of a tennis ball is typically about 33 centimeters, so I put in 0.003 meters. In the area here, it's pi r squared, because tennis ball's a circle. So to pull up this function, you just type in area on Matlab and type in the radius of your ball, which should be around 0.0033 meters. And here it gives you the area, which is a very tiny number in this case. And then my last function is used to calculate the drag force on the tennis ball in the air. It's a very important thing to keep into account if you want accuracy when you're trying to figure out where you want to hit the ball, because you always have to take into account the air drag and the angle you hit it, and if there's wind that day. All those things affect the ball. So here, this calculates one little part of it, the drag force, due to the flow of air. D stands for the density of air, which is a constant. It's 1.21 kilograms per meters cubed. A is the area, which we calculated in the last function, the area of the ball. And V is the speed of the ball. And then CD is the drag coefficient. And that's just a constant number. I had to look it up. For a tennis ball, it's 0.55. So the equation is the force, drag force, equals CD times A times D times V squared divided by 2. So to perform this in Matlab, similarly to the past functions, you just type in drag force. You enter in 0.55 for the drag coefficient, and this is your area, which you found up here in the third function. And then you type in 1.21 for the density of air. And then here is what changes the velocity, so you could put in any velocity with which you hit the tennis ball. Again, I put in 30 meters per second, so it calculates it to be 0.0102. In this case, it's a very small number. It makes a difference, though. And then relating the drag force to the velocity with which the tennis ball is hit, I decided to graph. So here, the velocity of the ball, I started at 10, stepped by 0.5, going to maximum of 156, seems about right. Here I have the drag coefficient, the area of the ball, the density of air, and then again my drag force equation, where it uses all of these numbers to calculate. And then I plotted the velocity of the ball versus the drag force, and it came out like this. As you can see, it's an exponential relationship between the initial velocity and drag force, which makes complete sense. Obviously, the faster the ball is going, the more of a drag force that's going to happen against the ball traveling in the opposite direction of which the ball is traveling. And this is kind of a fun part of my project. I made arrays in a way that could be very useful in your game of tennis to calculate how fast your average serve is, because that's something that tennis players are pretty competitive about, like how fast your serve is, can you serve it faster? Because if you have a fast serve, then chances are your opponent won't even be able to return it. So it's a very important aspect of the game. And in each set, or each game rather, you typically have about 4 serves. So here I just kind of put average numbers that say a varsity high school tennis player would have: 60 miles per hour, 73 miles per hour, 76 miles per hour, etc. And then here it comes out. So you have game 1, game 2, and game 3. It's set up very nicely. I did the same thing for second serve. Typically the second serve is a lot slower than the first serve because as a player you want to be more conservative so that you make sure you actually hit it in this time and not miss. So here, same thing. It came out very nicely. You have the first game, second game, and third game. And then to find out what your average serve is overall, I added up both of the first serve and second serve and divided them by 2. And then here you get your average serve speed for each game, each point even. So as you can see, it looks like this hypothetical situation, the third set would have been the most powerful serve, which makes sense because you've warmed up and you're more comfortable, so you're hitting the ball harder. Another fun part to this project that I just kind of added in is a script file, and it compares how good your serve, which you may have calculated from before using arrays, how good it is compared to where you should be standing, maybe. So it gives statistics about serving in tennis using if-else-if statements. So this script file is called tennis serve. So to run it here in Matlab, which I will demonstrate, you just type in tennis serve, and this question pops up: how fast is your serve? So in high school, mine was around 65, so I'll just say that. And it comes up and says that you're average for a varsity high school player, which makes sense. And then for each different number you type in, you can type anything, like we'd say 145 miles per hour, which is really fast. As good as tennis pros around the world, so you know you're extremely good if you have that fast of a serve. And then just for fun, 160 miles per hour. And you get fastest serve, the world record is 156, which was made a few years ago, I do believe. And so if by some chance you do have that fast of a serve, you should probably tell someone. So yeah, that is my MATLAB project. It was a lot of fun to make because it related to something that I was very interested in, and it helped me really see how the script and functions worked. So I hope you enjoyed, and thank you very much.